There is a hole in the universe 1 billion light-years wide. This is the BOOTES void, a staggering expanse of cosmic nothingness that rewrites the rules of reality itself. By the end of this exploration, you will understand how this void forces us to rethink the fundamental architecture of the cosmos. We will journey from its eerie discovery among the stars to the cutting-edge theories trying to explain why it exists at all. Is it a statistical fluke, a relic of the Big Bang, or evidence of physics we have yet to dream of? What does a place of such profound emptiness make you wonder about our own place in the grand scheme of things? Our universe is not a uniform sea of stars. Instead, it is woven together into a magnificent, intricate tapestry known as the cosmic web. Picture the frothy structure of a soap bubble or the delicate threads of a spider's silk, but on a scale so immense it defies comprehension. This is the true architecture of everything. After the Big Bang, tiny ripples in the fabric of reality were stretched to cosmic proportions by the universe's expansion. Gravity, acting over billions of years, patiently sculpted these ripples. It pulled dark matter and ordinary matter into dense knots where galaxies swarm together in glittering clusters. It stretched matter into long, luminous filaments that connect these clusters like celestial bridges. And between these great structures, gravity left vast, empty regions, bubbles of near nothingness we call cosmic voids. This web, with its balance of dense walls and empty spaces, is the universe's expected design. Voids are a natural, even necessary, part of the cosmic landscape. They are the negative space that gives the glowing filaments their definition. But what happens when one of those empty spaces is not just a bubble, but a cavern? When a void grows so impossibly large that it stops looking like part of the pattern and starts looking like a tear in the canvas itself, that is the profound mystery of the BOOTES void. It is not merely an empty room in the cosmic mansion. It is a missing wing, a gap so vast it challenges our very understanding of how the universe builds itself. The map they were creating was meant to reveal the cosmic web, but instead it revealed a hole. In the late 1970s and early 80s, a team of astronomers including Robert Kirshner, Augustus Oemler, Paul Schechter, and Stephen Schechtman were meticulously charting the universe. Their tool was Redshift, the stretching of light from distant galaxies that tells us how fast they are moving away from us, and by extension, how far away they are. This allowed them to build a three-dimensional map, plotting galaxies not just by their position in the sky, but by their depth in space. Their survey focused on the region of the constellation BOOTES, the herdsman. As the data points accumulated, a strange pattern, or rather, a lack of pattern, began to emerge. In a colossal volume of space, their instruments found almost nothing. Where the established models of cosmic structure predicted thousands of galaxies, their catalog showed only a scattering of lonely points. It was as if they had been surveying a vast forest, only to stumble upon a clearing so enormous you could not see the trees on the other side. This was not a small gap, it was a staggering emptiness. Officially identified in 1981, this region was named the BOOTES void. Its initial measurement was a sphere of nothingness roughly 250 million light-years across. To put that in perspective, if you placed our Milky Way galaxy at one edge of this void, you would have to travel for 250 million years at the speed of light before you found another major galaxy. Later observations would even suggest the true scale might be larger, approaching a mind-numbing 330 million light-years. The discovery sent a quiet shockwave through astronomy. It was exciting, a genuine and profound mystery, but it was also deeply unsettling. The void challenged a fundamental expectation that on the largest scales, the universe is roughly uniform. How could gravity, which patiently sculpted the magnificent cosmic web, leave behind a desert of this magnitude? What force, or what absence of force, could create a bubble of near-nothingness so vast it seemed to defy the very rules of cosmic construction? The map was complete, and it showed a blank spot that demanded an explanation. The sheer size of this void is where our intuition fails completely. We can say the words billion light years, but our minds have no real anchor for such a distance. To even begin, we must shrink the universe down to a human scale. Picture our entire galaxy, the Milky Way, a majestic spiral containing over 200 billion stars. Let us reduce it to the size of a single grain of sand. On this scale, the entire observable universe, all the galaxies we could ever hope to see, would be a sphere roughly the size of our planet Earth. Now, within that planet-sized sphere of sand grains, find the BOOTES void. It would not be a small gap. It would be a cavernous, empty space larger than a football stadium. A single grain of sand, our galaxy, would be lost in that staggering emptiness. This is not a local pothole in the cosmic road. This is a continent-sized sinkhole in the fabric of space itself. To understand why, we need to feel what a light year truly means. Light is the fastest thing in the universe. In one single second, it can race around the Earth 7.5 times. Now let that speed continue unrelenting for an entire year. The distance it covers in that year, nearly 5.88 trillion miles, is 1 light year. It is not just a measure of distance, it is a measure of time. Now multiply that by 1 billion. A billion light years is a span so profound that if a beam of light began its journey across the void from one edge, it would have started its voyage when the most complex life on Earth was just beginning to form in the ancient oceans. By the time that light finally reached the other side, dinosaurs would have risen, ruled, and vanished. Entire mountain ranges would have been born and eroded away. Humanity would have evolved, built civilizations, and looked up at the stars, completely unaware that this ancient messenger was finally completing its journey. This is the scale we are discussing. The BOOTES void is not a recent feature. It is a primordial structure, a fossilized imprint of the universe's infancy that has been stretching and growing for most of cosmic history. Its existence forces us to confront a simple, monumental question. How does a universe governed by gravity, which pulls matter together, create and preserve a desert of this magnitude for so long? The void is not an oddity. It is a fundamental clue written in negative space about the forces that shaped everything we see. Yet within this billion light-year desert, a handful of islands stubbornly persist. The BOOTES void is not a perfect vacuum. Scattered across its staggering emptiness are perhaps 60 lonely galaxies, adrift in an ocean of darkness so vast that each one is, on average, hundreds of millions of light years from its nearest neighbor. To find one of these celestial hermits, you would have to travel a distance equivalent to crossing our entire local group of galaxies thousands of times over. One of the most studied is a spiral galaxy known by the catalog number MCG +0138005. From our vantage point, it appears as a faint smudge of light, a single, isolated spark in the abyss. Its very existence is a profound puzzle. How does a galaxy form at all in a place with so little raw material? In the rich filaments and clusters of the cosmic web, galaxies are born from dense clouds of primordial gas, and they grow through frequent mergers and collisions with their neighbors, events that trigger furious bursts of new stars. But here in the void, there is no intergalactic wind, no cosmic traffic jam to provide that fuel and gravitational stimulation. These void galaxies are like solitary trees that manage to sprout in the middle of a vast, arid salt flat. Their survival tells a different story of cosmic life. Studies suggest these isolated galaxies are often irregular in shape, having never been sculpted by the gravitational tug of a crowded neighborhood. They tend to be rich in the cold gas needed to form stars, but they use it sparingly, forming new stars at a slow, steady, and quiet pace. They are not the brilliant, flashy metropolises of dense clusters. They are more like secluded, self-sufficient homesteads, conserving their resources over eons. This makes them a unique natural laboratory. By studying these lone wanderers, astronomers can isolate the fundamental processes of galaxy formation, stripped of all the chaotic interference of a crowded cosmos. They offer a pure test of our theories. How resilient is the recipe for a galaxy? What is the absolute minimum environment needed for one to ignite and endure? The void galaxies are not just curiosities. They are control experiments written across the sky, showing us that even in the most impoverished corners of the universe, the urge to gather light from darkness can still, against all odds, find a way. This journey into the void is also a journey back in time. To solve the mystery of its emptiness, we must become archaeologists of the cosmos, sifting through the echoes of the universe's birth. Our best map of that beginning is the Big Bang Theory, which tells us the infant universe was a hot, dense, and remarkably smooth sea of energy and particles. It was not perfectly uniform, however. Tiny, random quantum ripples, fluctuations smaller than a single atom, were imprinted on everything. These were the universe's first seeds. For the next several 100 million years, gravity acted as the master sculptor. In regions where those quantum ripples had created a tiny bit more density, gravity's pull was slightly stronger. It began to gently tug matter, both the dark matter we cannot see and the ordinary matter that makes up stars and planets, toward these seeds. Think of it like water slowly finding the lowest point in a landscape. Over cosmic timescales, this gentle tug became a powerful flow. Dense regions grew denser, evolving into the great walls and filaments of the cosmic web. The spaces between them, the voids, were the regions left behind. The BOOTES void, then, might not be the result of a cataclysm or a strange new force. It could simply be a fossil. It may have started as one of those primordial seeds, but one of a different kind, a seed of absence. By sheer random chance, this particular region of the early universe may have had a slightly lower density than average. When the great gravitational gathering began, this region had less to offer. As the universe expanded, this underdense patch expanded even faster relative to its surroundings, like a thin spot in a stretching rubber sheet. Matter was not pushed out, it was simply drawn away, pulled toward the gravitational pull of the denser regions growing around it. Over billions of years, this process of cosmic erosion left behind a cavern of staggering scale. So the void may not be an active, empty thing. It is likely a passive relic, a preserved imprint of a random microscopic quirk from the first moments of time, magnified to a scale we can barely comprehend. It is a silence that has been growing for almost the entire age of the universe. This explanation is elegant, fitting neatly within our standard model of cosmic evolution. But it also raises a new and profound question. Is a void this vast simply a rare but statistically possible roll of the cosmic dice, or does its extreme size hint that our understanding of those dice is somehow incomplete? Yet this elegant explanation runs into a formidable wall of mathematics. The lambda cold dark matter model is the bedrock of modern cosmology, a meticulously crafted framework that describes a universe dominated by dark energy and cold dark matter. It is our most successful cosmic blueprint, having predicted with astonishing accuracy the faint afterglow of the Big Bang, the abundance of light elements, and the overall frothy structure of the cosmic web we observe today. Within its simulations, voids naturally arise, and their predicted sizes and numbers generally match what we see in the sky. But then there is the BOOTES void. When cosmologists feed the lambda cold dark matter model's parameters into their most powerful supercomputers and let virtual universes evolve over billions of simulated years, they produce vast cosmic catalogs. In these digital skies, voids the size of the BOOTES void do occasionally appear, but they are extraordinarily rare. Finding one in our observable universe is statistically akin to rolling a cosmic dice 1,000 times and getting the same improbable number every single time. It is not impossible, but it makes scientists pause and double-check their calculations. The model allows for such a void, but it does not expect to see one so prominently in our particular cosmic backyard. This creates a fascinating tension, a quiet conundrum at the heart of cosmology. Is the BOOTES void simply that one-in-a-million statistical outlier, the universe's version of a lottery winner of emptiness? Or is its extreme nature a subtle clue, a whisper from the cosmos that our otherwise brilliant standard model is missing a small but crucial piece of the puzzle? Perhaps the primordial seeds were slightly different, or the interplay of dark energy and gravity played out in a unique way in this region. This is where the real science ignites, in the gap between what our theories predict and what the universe defiantly shows us. A mystery of this scale does not necessarily break our understanding, but it brilliantly stresses it, testing the limits of our best ideas and inviting us to look deeper. The statistical tension surrounding the void opens a door to more radical possibilities. When our best scientific frameworks are stretched to their limits by an observation, imagination is not just allowed, it becomes a necessary tool for exploration. This is where physicists armed with mathematics and a healthy dose of curiosity venture into the realm of highly speculative yet fascinating theoretical explanations. One such idea emerges from the concept of the multiverse. In certain cosmological models, our entire universe is just one expanding bubble in a frothing, infinite sea of other bubble universes, each with its own potentially different laws of physics. What if, in the distant cosmic past, our bubble universe gently brushed against another? The boundary of such a collision would not be a destructive crash, but a subtle, sweeping interaction. Theoretically, this interaction could have acted like a cosmic squeegee, gently pushing matter away from the contact zone as the universes repelled each other. The result, left to evolve for billions of years, could be a vast, cleaned-out region of space, a fossilized scar from a meeting of worlds we can never directly see. The BOOTES void in this breathtaking scenario would not be an absence but a signature, a permanent mark on our sky whispering of realities that lie forever beyond our observational horizon. Another profound speculation reaches even deeper into the fabric of reality itself. In the first fleeting moments after the Big Bang, as the fundamental forces of nature were settling into their current forms, the very structure of space-time may have undergone phase transitions, akin to water freezing into ice. Sometimes these transitions are not perfectly smooth. They can leave behind defects frozen in wrinkles in the fabric of reality known as cosmic textures. These are not made of matter but are knots and twists in spacetime itself. An exceptionally large cosmic texture, a topological flaw on a scale of hundreds of millions of light-years, could have a profound gravitational influence. As the universe expanded, this invisible knot would have repelled ordinary matter, creating a vast region of avoidance around it. The void we observe today could then be the ghostly imprint, the shadow, of this primordial defect in the quantum structure of everything. It is crucial to understand these are not mainstream theories, and they lack the direct evidence that supports our standard cosmological model. They exist at the very frontier of theoretical physics, beautiful mathematical possibilities that are incredibly difficult, if not currently impossible, to test. Yet their value is immense. They demonstrate how an anomaly like the BOOTES void acts as a powerful catalyst. It pushes scientists to ask the biggest questions, to rigorously explore the furthest implications of their own equations, and to dare to consider architectures of reality that defy our everyday intuition. The void is not just a puzzle to be solved within our current picture. It is a beacon that compels us to wonder if the picture itself is complete, or if we are merely seeing one corner of a canvas that stretches into dimensions we have yet to perceive. Mapping a billion light-year desert requires instruments of almost unimaginable sensitivity. To understand the true shape and scale of the BOOTES void, astronomers cannot simply point a telescope and take a photograph. They must become cosmic cartographers, building a three-dimensional atlas of the cosmos, one galaxy at a time. This monumental task is accomplished through massive, systematic projects known as Redshift surveys. The most famous of these, the Sloan Digital Sky Survey, has been a game-changer. From its perch on a mountaintop in New Mexico, this telescope does not just capture beautiful images. It uses a technique called spectroscopy to dissect the light from millions of faint, distant galaxies. By spreading that light into a rainbow-like spectrum, scientists can read a specific fingerprint, a shift toward the red end of the spectrum caused by the expansion of the universe. This redshift tells them precisely how fast a galaxy is moving away from us, and therefore its distance. Imagine trying to map a vast, dark forest by only being able to see the occasional flicker of a firefly. Each firefly's faint glow gives you its direction, but by carefully measuring the specific shade of its light, you can calculate exactly how far away it is in the darkness. The Sloan survey has done this for millions of cosmic fireflies, allowing scientists to plot their positions in a colossal three-dimensional grid. It is within this digital universe that the true, staggering contours of the BOOTES void become starkly visible, its boundaries etched by the abrupt, profound absence of data points. By counting the sparse galaxies within this digital cavern, astronomers can estimate its true density, confirming it is not just seemingly empty, but profoundly, measurably underdense compared to the rest of the cosmic web. Yet our map of this emptiness is necessarily incomplete, limited by the very nature of light and our technological reach. Our current surveys are magnificent, but they have a brightness threshold. They can reliably detect the larger, brighter galaxies adrift in the void, like spotting campfires on a plain. But what about the faint, smoldering embers? Dwarf galaxies, which are far more numerous in the universe, could be scattered throughout the void, too dim for our telescopes to see. Furthermore, there could be vast, diffuse clouds of hydrogen gas, the raw material of stars, drifting unseen through the darkness, invisible to the instruments designed to pinpoint stellar light. This means the BOOTES void might not be as utterly barren as it appears. It could host a hidden, faint population of celestial objects, a shadowy ecosystem we are simply not yet equipped to perceive. Our understanding is a sketch based on the brightest landmarks, and we must acknowledge the blank spaces on our own map. This is where the future of astronomy shines its light directly into the darkness. New eyes are turning toward the void. The James Webb Space Telescope, with its unprecedented infrared sensitivity, is like an instrument tuned to hear the faintest whispers from the early universe. It can peer through cosmic dust and detect the dim glow of some of the smallest, oldest galaxies. If there are faint dwarf galaxies or primordial gas clouds hiding within the BOOTES void, Webb offers our best chance to find them. Furthermore, the next generation of ground-based giants, like the extremely large telescope being built in Chile, will combine colossal light-gathering power with adaptive optics to cancel out the blurring effect of Earth's atmosphere. These observatories will act like cosmic microscopes, scrutinizing the void's emptiness with finer and finer detail. They will not just count galaxies, they will study the detailed properties of the void's lonely inhabitants, measuring their ages, their chemical compositions, and their star formation histories in exquisite detail. Each new piece of data is a brushstroke that fills in our portrait of this cosmic anomaly. With every technological leap, we are not just looking at the void, we are learning how to see it more clearly, transforming a shadowy abstraction into a precise laboratory for testing the laws of the cosmos. What we find there or confirm is missing will ultimately decide whether this great nothingness is a rare statistical fluke or a signpost pointing toward new physics. The BOOTES void is a profound mystery, but it is not the only one of its kind. Our universe is dotted with these vast cosmic deserts, each with its own unique character, and comparing them is like comparing different types of silence. One of the most intriguing is known as the KBC void, named for the astronomers who identified it, Keenan, Barger, and Coway. This void presents a startling and humbling fact. It is the one we actually live inside. Our Milky Way, along with our neighboring galaxies in the local group and our larger Virgo supercluster, resides within a gentle underdensity roughly 2 billion light-years across. This is not a stark emptiness like the BOOTES void, but more of a broad, shallow valley in the density of the cosmic web. We are not in a bustling downtown of the universe, but rather in a quiet suburban expanse. This discovery recalibrates our cosmic address and raises a fascinating question. Are we seeing the universe from a biased, unusually quiet point of view? Another giant is the void in Canes Venatusi, discovered in the late 1980s. With a diameter of around 1.3 billion light-years, it rivals the BOOTES void in sheer scale, yet its interior is not quite as desolate. It contains a few more galaxy clusters and strings, making it a slightly less extreme example of cosmic emptiness. These comparisons are crucial for science. By cataloging the sizes, shapes, and densities of many voids, cosmologists are building a statistical profile of the universe's negative space. They are asking, is the BOOTES void a true statistical monster, an outlier so extreme it breaks the mold? Or is it simply the largest member of a continuous family of voids, the natural end of a spectrum predicted by our models? The differences between them are telling. A void like the KBC, which is larger but less empty, suggests a different formation history, perhaps a region that was only mildly underdense from the start. The BOOTES void, with its stark emptiness, might represent a primordial seed of profound absence. By studying this population, scientists can run their simulations again and again, checking if the number of voids as large as BOOTES matches what the dice rolls of the early universe should produce. This broader context transforms a single anomaly into a data point. It allows researchers to distinguish between a mere rare event and a genuine tension, a pattern that might point toward something missing in our equations. So the next time you look up at the night sky, remember you are gazing out from within a gentle void, looking across the cosmic web toward others, each a unique laboratory of absence holding clues to the forces that arranged everything. This accelerating expansion is not driven by matter, but by something far more enigmatic, a force we call dark energy. Within the vast emptiness of the BOOTES void, this mysterious influence may find its purest, most powerful expression. Here, the cosmic tug-of-war takes on a strange new character. Across most of the universe, the inward pull of gravity from galaxies, gas, and dark matter acts as a brake, gently resisting the outward push of dark energy. It is a delicate balance that shapes the rate of expansion, but inside a void, the balance is broken. With so few galaxies and so little matter, the gravitational pull holding things together is extraordinarily weak. In this near vacuum, there is almost nothing to push against the repulsive force of dark energy. Think of it like a balloon with a thin spot. As you inflate it, the thin, weak section stretches faster and grows larger than the sturdy, reinforced areas. In the cosmic sense, dark energy acts as the constant breath inflating the universe, and the BOOTES void is that thin spot, expanding more rapidly than the dense filaments and clusters around it. This means the void is not a static fossil. It is likely an active, evolving entity. Over billions of years, it has probably been growing, becoming even emptier as the scant matter within it is pulled apart by this relentless, repulsive pressure. The galaxies that remain are not just isolated, They are being carried further from one another on a tide of expanding space that flows faster here than anywhere else. This transforms our view of the void entirely. It is no longer just a curious, empty place we observe. It has become a unique natural laboratory. By carefully measuring how fast the void is expanding compared to the universe at large, by studying the motions of its few lonely galaxies, cosmologists can take the temperature of dark energy itself. They can probe its strength and consistency in an environment where its effects are magnified, free from the complicating clutter of normal matter. In this way, the great nothingness of the BOOTES void offers us a clearer signal, a sharper lens through which to study the force that will dictate the ultimate fate of everything. The void's emptiness, therefore, is not merely an absence. It is an accelerant, a cosmic amplifier for the most profound mystery in modern physics. But the true nature of a void is not defined by what we can see, but by what we cannot. Even in this apparent emptiness, gravity leaves its subtle, indelible trace. While the BOOTES void contains shockingly few luminous galaxies, it might still hold significant amounts of dark matter, the invisible scaffolding upon which the entire cosmic web is draped. This mysterious substance does not emit, absorb, or reflect light, making it completely undetectable by our telescopes. Yet it exerts a powerful gravitational pull, shaping the universe from the shadows. So the critical question becomes, is the BOOTES void truly empty of all mass, or is it merely empty of light, a dark matter ghost town whose true structure remains hidden from our eyes? One ingenious method to answer this is by watching for the universe's own sleight of hand, a phenomenon called weak gravitational lensing. According to Einstein's theory of general relativity, mass warps the fabric of spacetime. When light from a distant background galaxy travels through the universe, its path is not perfectly straight. If it passes near a massive object like a cluster of galaxies, its trajectory bends like a marble rolling across a stretched sheet. This can create spectacular effects, like multiple images of the same galaxy or beautiful, stretched arcs of light. But within a vast void, the effect would be far more subtle. Instead of a strong, obvious bend, the sparse dark matter spread across that billion light-year expanse would create a collective, incredibly faint distortion. It would be like looking through a pane of glass with a barely perceptible flaw, one that subtly stretches and shears the shapes of every distant galaxy behind it. Astronomers search for this signal by statistically analyzing the shapes of millions of faint galaxies that lie in the sky beyond the void. If those galaxies appear ever so slightly stretched in a pattern that aligns with the void's boundaries, it would be the smoking gun, direct evidence that the BOOTES void is not a true vacuum, but a reservoir of invisible mass. The search for this weak lensing signal is an ongoing, painstaking effort, a testament to patience and precision. Its detection or its telling absence would provide a crucial clue. Finding a lensing effect would mean the void's gravity is stronger than its visible contents suggest, filled with dark matter that simply never coalesced into bright stars. This would support the idea that it is a natural, if extreme, part of the cosmic web's architecture. Not finding a lensing signal, however, would be even more startling. It would suggest the void is as gravitationally empty as it appears visually, a genuine hole in both the luminous and dark matter distribution. That would be a far greater challenge to our models, hinting at a formation process that somehow cleared out everything, leaving behind a purity of nothingness that defies our current understanding of how the cosmos organizes itself. So we are left watching for a whisper of distortion, a faint signature written in the bent light of galaxies billions of years old, hoping it will tell us whether this great nothingness is an illusion of our eyes, or a reality so profound it reshapes our grasp of the universe's hidden skeleton. The silence of the void speaks volumes about our place in the cosmos. While we marvel at the glittering tapestry of stars and galaxies, the BOOTES void forces us to confront a deeper, more unsettling truth, that the universe is not merely a stage for matter, but a vast theater dominated by emptiness. For every glowing galaxy, there are trillions of cubic light-years of profound nothingness. This cosmic desert challenges a very human instinct to see the universe as a place brimming with potential, designed with us in mind. Yet here is a region so immense, so devoid of the necessary ingredients, that the emergence of life within it is not just unlikely, it is virtually impossible across its entire billion light-year breadth. This realization carries a quiet, philosophical weight. It gently recalibrates our perspective. We are not the center of a universe crafted for our habitation. We are inhabitants of an extraordinary but exceedingly rare oasis. Our galaxy, our solar system, our world, exists in a privileged neighborhood of the cosmic web, a dense knot where conditions aligned perfectly over billions of years. The void reminds us that our existence is the product of spectacularly good fortune, a precious exception in a cosmos where the default setting is often barren, empty space. This is not a cause for despair, but for a profound and humbling awe. It shifts the narrative from a universe made for us to a universe in which we have, against staggering odds, managed to arise and look back upon its mysteries. The void becomes a mirror, reflecting not just the absence of stars, but the fragility and rarity of our own condition. It asks us what it means to be alive in a reality that can contain such absolute, indifferent emptiness. In this way, the great nothingness is not meaningless, it is rich with implication. It serves as the ultimate negative space, the dark background against which the precious spark of our existence shines all the brighter, compelling us to consider not just where we are, but what our presence signifies in a cosmos capable of such scale and silence. The human mind is a storyteller, and it cannot abide a blank page. For millennia, we have filled the unknown corners of our world maps with illustrations of sea monsters and the words "Here be dragons." The BOOTES void is our modern dragon, a blank space on the cosmic map so vast it demands a story. In the realm of science fiction and art, this great nothingness has become a canvas for our deepest cosmic anxieties and our wildest speculations. It is reimagined as the ultimate forbidden zone, a billion light-year wide anomaly that starships must navigate around in epic space operas. Within its dark borders, writers and filmmakers imagine lost civilizations that fled the crowded galaxy to hide in perfect isolation, or ancient, universe-spanning artifacts left dormant in the silence. It becomes a region where the laws of physics break down, where time flows differently, or where reality itself wears thin, offering a doorway to other dimensions. These are not scientific proposals, but they are profoundly human reactions. They represent our instinct to anthropomorphize the cosmos, to transform a statistical anomaly into a narrative entity with purpose, danger, or hidden treasure. This creative impulse is more than just entertainment. It serves a vital function in our relationship with discovery. A compelling novel or a gripping film that uses the void as a plot device does something remarkable. It takes an abstract, intimidating cosmological concept and wraps it in the accessible language of adventure and mystery. It sparks a viewer's or reader's curiosity in a way a textbook graph cannot. Someone who first encounters the BOOTES void in a story may be inspired to look up the real science, to learn about redshift surveys and cosmic inflation. In this way, fiction becomes a gateway, a popularizer that brings the farthest frontiers of astronomy into the public imagination. It creates a shared cultural reference point for a concept that is otherwise almost impossible to visualize. This dialogue between science and art is a beautiful feedback loop. Scientists reveal a staggering truth about the universe, and artists translate that truth into myth and metaphor, which in turn fuels public wonder and support for further scientific exploration. The void, therefore, exists in two parallel spaces, in the meticulous data sets of astronomers and in the speculative dreams of storytellers. Both are essential. One gives us facts, the other gives those facts meaning and emotional weight. They remind us that the urge to explain the cosmos and the urge to mythologize it spring from the same source, a deep, enduring need to find our place within the overwhelming grandeur of it all. The greatest mysteries are not just puzzles to be solved, they are wells of inspiration from which both knowledge and wonder endlessly flow. The ultimate verdict on this cosmic emptiness will be written by the next generation of eyes we turn toward the darkness. Our current maps are magnificent, but they are like sketches compared to the high-definition portraits soon to be painted by a new wave of space observatories. The European Space Agency's Euclid mission already on its way, and a forthcoming Nancy Grace Roman Space Telescope are not designed to look at single objects, but to conduct vast, sweeping cosmic censuses. Think of them not as telephoto lenses, but as the most powerful wide-angle cameras ever built, capable of capturing enormous swaths of the sky in a single, deep gaze. Their primary mission is to chart the dark universe, mapping the influence of dark matter and dark energy by observing the shapes and positions of billions of galaxies. In doing so, they will inevitably produce the most detailed three-dimensional atlas of the cosmic web ever created, and within that atlas, the BOOTES void will be rendered with stunning new clarity. By measuring the precise redshifts of countless faint galaxies around and within the void's borders, these telescopes will allow scientists to reconstruct its true geometry, to see if its walls are smooth or ragged, and to pinpoint every last, lonely galaxy adrift inside with a census far more complete than any before. This flood of data will also supercharge the search for the void's weak gravitational lensing signal. With billions of background galaxy shapes to analyze, the statistical power to detect that subtle, universe-bending distortion will increase exponentially. A clear detection would finally reveal the void's hidden mass, while a continued absence would make the case for its profound emptiness even stronger. Beyond the realm of visible light, other senses are tuning in. Vast radio astronomy arrays, like the square-kilometer array being planned across two continents, will listen to the universe in wavelengths our eyes cannot see. Their specialty will be detecting the faint radio whisper of neutral hydrogen gas, the primordial fuel for stars. By sweeping their collective gaze across the BOOTES void, they could potentially map vast, invisible reservoirs of this gas drifting unseen through the darkness, or confirm its startling absence. Each new dataset from these future missions will be a piece of evidence in a grand cosmic trial. Is the BOOTES void a one in a trillion statistical fluke, a roll of the dice so rare we just happen to see it? Or does its persistent, extreme nature contain a coded message, a sign that our standard model of cosmology, for all its brilliance, is missing a subtle clause in the contract of creation? The void itself will not change, but our understanding of it is on the verge of a revolution. We are building the instruments that will finally let the emptiness speak for itself, and what it says may quietly redefine our place in the story of everything. These digital universes are our most powerful tools for interrogating the void. To ask whether the BOOTES void is a strange accident or an expected feature, scientists do not just look at the sky, they build entire cosmos from scratch inside the world's most powerful supercomputers. This begins with a set of assumptions, the foundational recipe of our reality. The simulation starts with a digital box representing a chunk of space and fills it with a smooth, almost uniform sea of particles representing dark matter and ordinary matter. But it is not perfectly smooth. It is seeded with those same tiny, random quantum ripples we believe existed in the infant universe. Then, with the press of a button, the simulation begins. The clock starts ticking at a fraction of a second after the Big Bang, and for the next 13.8 billion virtual years, the unyielding laws of physics take over. Gravity, coded into every line of the program, begins its patient work. It tugs at those particles, amplifying the dense spots and draining the sparse ones. Over eons of compressed processing time, a magnificent structure emerges from the chaos, a shimmering cosmic web of dark matter filaments and halos. Within that web, voids naturally bubble into existence, their sizes and numbers a direct product of the initial recipe. The most famous of these virtual creations is the Millennium Simulation, a landmark project that used more than 10 billion particles to trace the evolution of a universe 2 billion light-years on a side. Running this simulation required months of supercomputer time, but the result was a breathtaking digital cosmos, a complete and dynamic atlas of structure formation that researchers can explore like a video game of universal history. By analyzing thousands of such simulated universes, each with slightly different random starting ripples, cosmologists build up a statistical expectation. They can count, on average, how many voids of a certain size should appear in a volume of space as large as our observable universe. This is where the BOOTES void presents its quiet challenge. When scientists sift through these vast digital catalogs, they do find enormous voids, but a void as profoundly empty and as staggeringly large as the BOOTES void is a rare guest in the simulation data. It is not absent, but it appears so infrequently that finding one in our particular real universe feels like a remarkable coincidence. These simulations are not just passive comparisons, they are active laboratories. Researchers can perform experiments impossible in reality. They can tweak the initial conditions, slightly altering the strength of dark energy or the properties of dark matter, and then run the simulation again to see if such extreme voids become more common. They can rewind the digital timeline and follow the precise history of a simulated void that matches BOOTES, watching how every galaxy was gravitationally pushed and pulled over billions of years to create that final cavern of emptiness. This virtual archaeology provides a narrative for the void's life story, from its birth as a microscopic underdensity to its present-day status as a cosmic titan. So the next time you hear about a new discovery in cosmology, remember that it was likely preceded by countless digital big bangs, trillions of lines of code enacting gravity's grand play, all to answer one simple, profound question. Does our universe, with its one giant void, look like a typical member of a vast ensemble of possible worlds, or does it stand out as uniquely strange? The simulations suggest we may be living in a slightly unusual neighborhood, and that very suggestion is what drives science forward, from the silicon hearts of supercomputers back to the silent, starless depths of the sky. Even the deepest cosmic deserts are not completely empty. Between the scattered galaxies of the BOOTES void drifts an almost unimaginably thin gas, known as the Intergalactic Medium. This is not the cold, dense fuel from which stars are born, but a searingly hot, wispy plasma so diffuse that a single cubic meter of it might contain only a single atom. In the rich neighborhoods of the cosmic web, this medium is constantly stirred and heated by the energetic winds from exploding stars and the fierce radiation from supermassive black holes. But within the profound quiet of the void, conditions are different. Here, the intergalactic medium is expected to be even more tenuous and far more pristine, like a still, undisturbed pool that has not felt a ripple in billions of years. Studying this ghostly material is like performing a chemical analysis on the void's atmosphere. By measuring its temperature, its density, and whether its atoms are intact or stripped of their electrons, astronomers can read a hidden history book. The state of this gas records every major energy event that has ever occurred in this region. If the void was once home to brilliant quasars or bustling galaxies that have since faded or moved away, their powerful radiation and galactic winds would have left a permanent scar, heating and ionizing the gas. Conversely, if the gas is found to be cooler and less disturbed than expected, it would suggest this region has been a quiet backwater since the dawn of time, a place where the great cosmic dramas of star formation and black hole activity simply never played out. To detect this faint, hot material, we must look with the right eyes. Ordinary optical telescopes see nothing. We need observatories that see the universe in X-ray and ultraviolet light, the precise wavelengths emitted by this superheated, diffuse plasma. Missions like the Chandra X-ray Observatory and future space telescopes designed for ultraviolet astronomy are our only tools for this delicate task. They scan the void not for points of light but for an ultra-faint, uniform glow, a whisper of energy spread across 1 billion light-years. Each photon they collect from this glow is a precious clue. So the story of the BOOTES void is not written only in the galaxies that are absent, but also in the faint, hot breath that remains. Is that breath calm and cool, hinting at an eternal silence, or is it agitated and warm, bearing the faint, fossilized echoes of a vibrant past that has long since vanished? The answer lies in a signal so faint it tests the very limits of our technology, waiting to tell us if this great nothingness was born empty, or if it was once a somewhere that was meticulously, mysteriously cleared. This cosmic emptiness is a window not just into the past, but into the final chapter of our universe. The evolution of these vast voids is intimately woven with the ultimate fate of everything, dictated by the relentless push of dark energy. As this mysterious force drives the accelerated expansion of space, the magnificent cosmic web we see today will not hold its shape forever. The delicate filaments and walls, the grand architecture sculpted by gravity over billions of years, will begin to stretch and thin. Think of a spider's web caught in a steady, ever stronger breeze. The silken threads will pull taut, then slowly separate, and finally they will snap. In the cosmic sense, this process will unfold over trillions of years. Voids like the one in BOOTES will not remain static. They will actively grow, their boundaries expanding as the space within them stretches faster than the surrounding denser regions. Neighboring voids will eventually meet and merge, creating ever larger deserts of nothingness. Meanwhile, the rich clusters and superclusters of galaxies, the glittering cities of the cosmos, will find themselves increasingly isolated. They will become lonely islands in a darkening sea, their gravitational connections to other islands severed by the rushing expansion of the void between them. This leads to a staggering vision of the far future, a time so distant it defies all human scales. The universe may transform into a vast, cold, and nearly uniform sea of expanding emptiness. The brilliant tapestry of the cosmic web will have faded, leaving behind only rare, isolated stellar systems, glowing like the last embers in a fire that has burned for eons. In this context, the BOOTES void is more than a curiosity. It is a present-day preview, a snapshot of the dominant environment our cosmos is evolving toward. By meticulously studying its current rate of growth, the motions of its few galaxies, and the properties of its sparse intergalactic gas, we are not just analyzing a single anomaly. We are calibrating a timeline. We are gaining crucial insight into the long-term trajectory of all structure in the universe. This research paints a profound and humbling picture of destiny, not of a grand cosmic cycle or a fiery collapse, but of a slow, quiet fade into cold, diffuse isolation. The great silence of the void, therefore, is not an ending but a key. It helps us listen to the deep rhythm of the cosmos, a rhythm that tells us all stories, even the story of the universe itself, eventually reach their final page. A common reaction to the BOOTES void is to fill its emptiness with fear or misunderstanding. It is crucial to separate the awe-inspiring reality from the persistent myths that swirl around it. The first and most important correction is that this is not a literal hole, a tear in the fabric of space-time where existence ends. The void is a region of perfectly normal space, governed by the same laws of physics as everywhere else. Its profound mystery lies not in a missing piece of reality, but in a staggering absence of the luminous matter we use to map it. Think of it not as a bottomless pit, but as an unimaginably vast, nearly empty plain under the same sky as the rest of the cosmos. This leads directly to the second, often unspoken worry. Is this void a threat? Could our Milky Way galaxy one day be swallowed by this nothingness? The answer is a firm and reassuring no. The BOOTES void is not a gravitational sinkhole actively pulling things in. It is, in fact, gravitationally uninteresting, offering little pull compared to the massive clusters and superclusters that anchor our local cosmic web. We are not falling toward it, we are being carried along with the overall expansion of the universe, a flow that keeps us securely within our own filament of the great cosmic tapestry, billions of light years from its silent borders. Another misconception positions the void as evidence against the Big Bang itself. This could not be further from the truth. The void does not contradict our foundational story of cosmic origins, it refines it. The Big Bang theory does not predict a perfectly smooth, uniform distribution of matter today. It predicts the opposite, a universe textured by gravity amplifying tiny initial ripples. The BOOTES void is one possible, if extreme, outcome of that very process. It challenges the specifics, the statistical likelihood within our models, but not the grand narrative itself. Finally, we must remember that its name is a bit of a misnomer. The BOOTES void is not a perfect vacuum. As we have explored, it hosts a sparse population of lonely galaxies and a thin, hot medium of intergalactic gas. Its emptiness is relative, a profound underdensity rather than an absolute nothing. By gently setting aside these myths, we clear the space to see the void for what it truly represents, not a cosmic error or a terrifying abyss, but a natural feature. It is an extreme example of the universe's capacity for variety, a laboratory of absence that exists within the rules, inviting us to understand those rules more deeply than we ever thought possible. Behind every cosmic map is a team of people staring at data, asking questions. The discovery of the BOOTES void is not just a story about a place, it is a story about a moment of human realization. Astronomers Robert Kirshner, Augustus Oemler, Paul Schechter, and Stephen Schechtman were engaged in the slow, meticulous work of cosmic cartography. Their goal was not to find a giant hole in the universe, but to understand the large-scale structure of everything, to trace the outlines of the cosmic web. They were using some of the most advanced tools of their era, like sensitive photometers and early computer analysis, to measure the redshifts of galaxies in a specific patch of sky centered on the constellation BOOTES. This was not a quick process. It involved long nights at the telescope, painstaking calibration, and the careful compilation of thousands of data points into a three-dimensional model. For months they gathered the dots of light, each one a distant island universe, and then the pattern or the profound lack of one began to emerge from the numbers. Where their models predicted a scattered but consistent population, their data showed a staggering drop-off. A vast volume of their map was coming up empty. Imagine the quiet conversation that must have happened, the double-checking of instruments, the recalculation of coordinates, the growing certainty that they were not looking at an error, but at a feature. A feature of nothing. To publish such a finding required a certain intellectual courage. It was one thing to propose a new type of galaxy or a distant quasar. It was another to announce the discovery of a billion-light-year-wide absence that seemed to defy the established understanding of how matter was distributed. They had to present evidence so clear that the scientific community would accept this counterintuitive reality. Their 1981 paper, calmly titled "A Million Cubic Megaparsec Void in BOOTES," was that evidence. It presented the data, outlined the methods, and stated the astonishing conclusion. that the universe contained a region of profound emptiness on a scale previously thought improbable. This human element is crucial. It reminds us that science is not a machine that automatically generates truth. It is a deeply human endeavor, a process driven by curiosity, fortified by patience, and validated by the willingness to follow the data, even when it leads to a startling and unexpected silence. The story of the BOOTES void, therefore, begins not with the void itself, but with the astronomers who had the patience to listen to what the cosmos was telling them, and the clarity to recognize the significance of a whisper in the data. The profound emptiness of the BOOTES void does more than challenge experts. It illuminates the cosmos for everyone. This staggering cosmic desert has become an unexpectedly powerful classroom, a gateway for making the universe's grandest ideas feel real. How do you teach a student about the structure of everything, a concept so vast it defies ordinary thought? You show them the void. Its extreme nature acts as a perfect anchor, transforming the abstract cosmic web from a fuzzy diagram into a tangible architecture. You can point to the void and say, "See this enormous empty space. This is the negative space, the bubble between the glittering filaments." It gives the web its shape, making the concept of large-scale structure suddenly concrete and visually striking. Educators use this mystery to demonstrate foundational principles in a memorable way. The cosmological principle, the idea that the universe is roughly the same in all directions when viewed on a large enough scale, is a tricky notion. The void seems to violate it, but that very tension is the teachable moment. It allows a teacher to explain that the principle applies statistically across the entire observable universe, and that rare, extreme outliers like the BOOTES void are actually permitted within the model. This leads directly into a lesson on probability and statistics in science, showing how cosmologists use vast surveys and computer simulations to determine if something is merely rare or genuinely anomalous. It is a masterclass in the scientific method itself, moving from the initial observation of an unexpected emptiness to forming hypotheses about its origin, to testing those ideas against new data and sophisticated simulations. Technology now brings this lesson to life in breathtaking ways. Interactive planetarium shows and educational software allow students to take a virtual journey, flying at impossible speeds through a digital model of the observable universe. They can zoom past swirling galaxies, travel along luminous filaments, and then, suddenly, enter the breathtaking quiet of the BOOTES void. That experiential shift from a crowded stellar metropolis to an endless, starless expanse creates a visceral understanding no textbook paragraph ever could. It makes the scale and the mystery personal. By focusing on such a captivating puzzle, educators do more than transmit facts. They ignite a spark of wonder and critical thinking. They demonstrate that science is not a static set of answers, but a dynamic process of inquiry driven by the universe's most stubborn mysteries. The void teaches that it is okay not to know, and that the pursuit of an explanation is a grand adventure that reshapes our entire view of reality. In this way, a billion-light-year patch of nothingness becomes one of our most valuable tools for inspiring the next generation of explorers, thinkers, and cosmic cartographers. Yet this cosmic perspective carries a quiet, ethical weight. When we truly grasp the scale of the BOOTES void, a billion light-years of profound emptiness, something shifts within our understanding of home. That staggering scale can induce a feeling often called cosmic humility. It is the visceral realization that our entire world, with all its history, its cultures, and its conflicts, is smaller than a single grain of sand on a stadium-sized beach. We exist on a fragile, isolated oasis of life in a cosmos where the default condition is often silent, empty space. This realization is not meant to diminish our significance, but to reframe it with breathtaking clarity. All of human endeavor, every triumph and every hardship, unfolds on a tiny, precious speck adrift in an ocean of cosmic nothingness. From this vantage point, the artificial lines we draw on maps, the divisions we emphasize, begin to look like patterns etched on the surface of that single grain of sand. The void offers us a mirror, reflecting not just our physical smallness, but the profound preciousness of our shared circumstance. It challenges us to ask a simple, powerful question. If our planet is this rare, this isolated, and this fragile in the grand scheme, does that not place upon us a shared responsibility for its care? This is where astronomy touches something deeply human. Studying a distant, empty region of space becomes more than an intellectual puzzle. It becomes an indirect source of perspective, a reminder that we are all crew members on the same small vessel, traveling together through an immense and indifferent sea. The cosmic silence of the BOOTES void, therefore, whispers a call for stewardship. It highlights that our biosphere, with its delicate and interconnected systems, is not just our home, but a singular achievement in a universe of voids. This perspective does not solve our problems, but it can inspire the mindset needed to address them, fostering a sense of global unity born from a shared, humbling view from the cosmic depths. In the end, the greatest gift of studying such emptiness may be the clarity it brings to what we must cherish and protect right here, in our crowded, vibrant, and irreplaceable corner of the light. The drive to see the faintest whispers of the cosmos forces us to build better eyes. Every attempt to map the profound emptiness of the BOOTES void, to detect its sparse galaxies or measure its subtle gravitational influence, stretches our technological capabilities to the absolute limit. This relentless push against the boundaries of the possible does far more than satisfy our curiosity about a distant void. It becomes a powerful engine for innovation, spinning off new technologies that quietly reshape our daily lives in unexpected ways. To study a billion light-year desert, we first need to capture the faintest possible light. This demand has driven the evolution of charge-coupled device sensors, the digital retinas of our telescopes, to unprecedented levels of sensitivity and low noise. These are not just better camera chips. The same core technology, refined in the extreme environment of astrophysics, now forms the heart of medical imaging devices. The exquisite sensors developed to detect a single photon from a distant galaxy can be adapted to create clearer, lower-dose X-ray images or more precise tools for diagnosing illness, translating the search for cosmic light into a clearer view of the human body. Then comes the tidal wave of data. A single deep sky survey doesn't produce a pretty picture. It generates petabytes of raw information, a digital universe of noise and faint signals. Finding a handful of lonely galaxies in that sea of data requires sophisticated algorithms, self-teaching software that can distinguish meaningful patterns from random chaos. These big data analytics, forged in the fires of cosmological research, have found a second home. The same pattern recognition techniques used to identify a faint smudge of a void galaxy are now adapted to scan medical images for early signs of disease, to analyze satellite imagery for environmental changes, or to improve the accuracy of facial recognition systems. Even the pure pursuit of better vision has cascading effects. The challenge of building larger, more stable telescope mirrors with perfect curvature pushes the frontiers of materials science and optical engineering. The solutions developed, from advanced polishing techniques to adaptive optics systems that cancel out atmospheric blur, eventually filter down into manufacturing, improving the lenses in everything from consumer cameras to the precision lasers used in surgery and telecommunications. This is the hidden, practical echo of our cosmic questions. The quest to understand a place of profound nothingness compels us to create tools of exquisite somethingness. It demonstrates a powerful truth about fundamental science. Investing in curiosity-driven research, in questions that seem to have no immediate application, is never just about the answers we find in the stars. It is an investment in the problem-solving capacity of our entire species. The technological seeds planted to explore the void inevitably take root and bloom in fields far from astronomy, yielding a harvest of innovation that touches medicine, communication, and computing. The great silence of the BOOTES void, therefore, speaks to us in more than one language. It whispers of cosmic history in the language of redshift and gravity, and it speaks of human ingenuity in the language of sensors, algorithms, and light. This profound isolation raises a fascinating question about the potential for life. Could the BOOTES void, a place of such staggering emptiness, ever be a home for intelligence beyond our own? For scientists involved in the search for extraterrestrial intelligence, this cosmic desert presents a paradox of possibilities. Its very nature is a double-edged sword. On one side, the extreme quiet could be a cosmic blessing. The void is largely free from the violent, chaotic events that regularly reshape more crowded galactic neighborhoods. There are no nearby supernova explosions to bathe planets in sterilizing radiation. There is little risk of gravitational disruption from a passing star, a cosmic event that could fling a world from its stable orbit into the frozen depths of interstellar space. This offers the potential for an environment of unparalleled stability, where a planetary system could exist in serene quiet for billions upon billions of years. In such a place, a civilization might have the ultimate gift, time. It could develop, evolve, and mature over eons without cosmic interruption, potentially reaching levels of technological or philosophical sophistication we can scarcely imagine. Yet the other edge of that sword is just as sharp. This stability comes at a profound cost, a scarcity of the very building blocks of cosmic society. In the rich galactic clusters and bustling spiral arms, stars are born from dense clouds of gas and dust, and they are often surrounded by the rocky debris that coalesces into planets, asteroids, and comets. These materials are the essential ingredients for life as we know it, and later, for the technological advancement that might allow a species to reach for the stars. But in the void, the primordial gas was too thin, the gravitational seeds too weak. The formation of stars themselves is a rare event here, and the creation of complex planetary systems around those stars would be rarer still. Any civilization that did arise on a world within the void would find itself in a position of profound material poverty. There would be no nearby asteroid belts to mine for metals, no neighboring star systems to visit, no bustling interstellar trade routes of any kind. They would be, in the most literal sense, an island universe. The very act of becoming a spacefaring species, which for us was spurred by a curiosity about our nearby moon and planets, might never even occur to a culture whose night sky showed only a handful of distant, unreachable points of light. This makes the BOOTES void an unlikely primary target for our current SETI efforts, which naturally focus radio telescopes on star systems more similar to our own, in richer galactic environments. Yet its existence serves a crucial purpose for our imagination. It forces us to confront our own assumptions. We tend to search for life in places that look like home, in neighborhoods that resemble our own crowded spiral arm of the Milky Way. The void challenges that bias. It whispers that life, in its stubborn, miraculous way, might find a foothold in the most unexpected of places, under conditions we would deem impossibly barren. Intelligence might not require a bustling cosmic metropolis. It could be a solitary flame, burning quietly and independently in the vast dark, its history and its destiny shaped entirely by its own isolation. The void, therefore, expands the canvas of possibility. It reminds us that if we are ever to find company in the cosmos, we must be prepared for the fact that it may not look, think, or build anything like us, and its home may be a silence we have only just begun to perceive. The BOOTES void is a question written across the cosmos in letters of emptiness. It does not provide easy answers, but it offers something far more valuable for our understanding: a perfect lens through which to examine the very nature of scientific knowledge itself. This vast cosmic desert is a living testament to the beautiful, necessary incompleteness of our current models. Our lambda-cold dark matter framework is a masterpiece of human intellect, capable of predicting the cosmic microwave background and the large-scale structure of the web. Yet it stumbles ever so slightly when asked to account for a void of this staggering scale with comfortable certainty. This is not a failure of science, it is science in its purest form. A true mystery does not shatter our understanding, it stresses it, revealing where the edges of our knowledge are and inviting us to push them further. The void is a cosmic coach, constantly reminding the scientific community that no theory, no matter how elegant, should ever become too comfortable. It forces a healthy, productive humility, compelling researchers to question their assumptions, refine their simulations, and occasionally dare to radically rethink foundational ideas. This process of challenge and refinement is the engine of discovery. Without anomalies like the BOOTES void, cosmology could risk becoming a closed book, a story we believe we have fully told. The void ensures the story remains open, its next chapter yet to be written. Simultaneously, this billion light-year expanse stands as a permanent monument to scale, a demonstration that the universe operates on a stage far beyond the limits of human intuition. Our minds evolved to navigate a world of trees, rivers, and mountains, not to grasp distances so vast that light becomes a slow crawl across eons. The void defies our innate sense of proportion. It makes a mockery of our local concerns, stretching the canvas of reality to a size where our entire galactic neighborhood becomes a microscopic speck. This is its second great lesson, that the cosmos is under no obligation to make sense to our parochial senses. It exists according to its own grand, often indifferent, logic. And yet, here is the profound counterpoint, the twist in the narrative. Despite being creatures of this small world, we have, through centuries of accumulated curiosity and ingenuity, built the tools to detect this nothingness. We have crafted telescopes that can measure the redshift of the faintest smudge of light, conceived theories of gravity and expansion that give this emptiness context, and built supercomputers to simulate its possible origins. We have managed to not only find this void but to measure it, map its contours, and debate its meaning. That is the quiet triumph at the heart of this journey. So our exploration of the BOOTES void becomes more than a catalogue of facts about an empty place. It transforms into a story about the human spirit. It is a narrative about the relentless, almost defiant, drive to comprehend the incomprehensible. We look into a billion light-year abyss, and instead of turning away in fear or resignation, we lean in. We point our instruments toward the darkness and ask it to speak. We fill the silence with our questions, our hypotheses, and our awe. This void, in all its majestic emptiness, ultimately reflects back to us our own boundless capacity for wonder and our stubborn refusal to accept that any corner of reality, no matter how vast or silent, is beyond the reach of our inquiry. It reminds us that the universe's greatest mysteries are not walls to stop us, but invitations to grow, to think bigger, and to continually rediscover our place within the grand, unfolding story of everything. Our voyage into the heart of this great nothingness has taken us from the intricate cosmic web to the frontiers of theoretical physics. We have seen that this billion light-year patch of cosmic nothingness is far more than empty space. It is a dynamic, challenging, and profoundly informative feature of our universe. Its silence speaks of the universe's capacity for staggering scale and its willingness to defy our simplest expectations. This emptiness holds its own secrets, teaching us that understanding the gaps in the cosmos is just as vital as understanding its bright spots. In the end, the BOOTES void is a masterclass in perspective. It shrinks our local concerns to their true size against the cosmic backdrop, while simultaneously expanding our sense of wonder at what is possible. It is a fossil of the primordial universe, a laboratory for dark energy, and a catalyst for technological innovation all at once. As we continue to build the next generation of eyes to map the heavens, let this colossal void stand as a permanent symbol. It is a reminder that the greatest discoveries often begin not with a brilliant light, but with a curious, profound absence. The universe is still writing its story, and some of its most compelling chapters are written in the quiet spaces between the stars. If you found this journey through the void fascinating, be sure to subscribe for more deep dives into the universe's greatest puzzles, and share your thoughts on this colossal nothingness in the comments below.